Trees absorb carbon dioxide, but they release it during the night and when they decompose. So Professor Klaus Lackner and engineer Alan Wright have been designing a tree which could be more efficient than the real thing. It was here at Biosphere 2 in Arizona that the idea was first conceived. Biosphere 2 was the largest completely airtight artificial ecosystem ever built, the perfect place to study how changes in carbon dioxide would affect the planet. After working on several prototypes, Klaus and Alan now think they might have finally cracked it. This was an early design, more like a cabinet than a tree. Inside, a plastic that absorbs CO2.
These plastics are ion exchange resins, which are commonly used in water preparation. If you desalinate water or make deionized water, this is the kind of stuff you would use. You can buy it commercially in large quantities.
At first, they used chemicals to wash the CO2 out of the plastic so it could be reused. But this needed too much energy to be viable. Then they made a discovery that was quite simple.
Maybe take the bell jar off.
It happened after they'd set up a basic experiment using nothing more than an airtight bell jar hooked up to a carbon dioxide monitor. An experiment they repeated for me.
Here on top you see the plastic material which absorbs the CO2. It has been wrapped in thin strips around the frame.
The level of CO2 in the bell jar starts at 386, today's atmospheric levels. As expected, the plastic immediately absorbs it. So
Yes.
the levels of CO2 in here are really low, round about 140. Okay? But what they do next, they feel is the real breakthrough, and so simple. They dunk the plastic in water.
And we'll just put it back in there.
Close it again. Now the air inside cannot escape.
Back in the bell jar, the wet plastic immediately starts to release the absorbed CO2. Okay, and the levels are already going up.
Yes.
So we're going to see it's beginning to trend up, and it will pick up over time as the CO2 is given off by that material.
So just by making it wet, it's now releasing the CO2 that was previously trapped.
Yes. When it's wet, it doesn't want the CO2, so it pushes it off.
It's as simple as that.
It's as simple as that.
It's amazing.
It is, and then you can dry it out again.
And when it dries out again, it will grab more CO2.
We'll do this over and over and over and over
And
again.
you can literally do this hundreds and hundreds of times.
Having ensured that rainfall will not release the CO2, Alan and Klaus are now building a full-scale artificial tree. When finished, it will have a central drum with panels of the special plastic and a humidity control system. By altering the moisture levels, it will absorb and then release the CO2 for storage. This process requires no chemicals, only a very small amount of energy and a water supply.
The vision of the future for these kind of artificial trees is that they can capture the carbon dioxide nobody else can capture. That's their advantage, that is their strength.
They estimate that a single tree will absorb about a ton of CO2 a day, about 75 cars worth. 60 million trees could potentially absorb all the CO2 we currently emit. And that's not all.
This is one of the few options available to actually go back and reduce the carbon dioxide level in the atmosphere from the level we are already at or will be in 50 years from now, back down to where it is safe.
All this absorbed carbon dioxide would of course need to be put somewhere. But that's where other new technologies come in, like the geological storage of CO2 that's being tested in Utah. And because CO2 levels are the same around the planet, a great forest of artificial trees could be placed right on top of storage sites. So the CO2 wouldn't have to be transported.